CIT 1122 packet tracer video for 519. There are no other packet tracers for 519, and this one has no points to score, which is disappointing because in the last version of this course there was some packet tracers with points to be scored for spanning tree protocol. And I'm not sure where they went, considering finding them and putting them out there. In the meantime, we can spend just a couple of minutes and go through this packet tracer. It's really, really straightforward. It's just a topology with 3 switches that are connected. That makes a loop, right? It's a triangle, but it's still a loop. So traffic that originates from PC1 and traffic that originates from PC2 could potentially go all the way around and never leave the carousel in either direction, right? So what we need to do is we need to pick a leader, and in the words of spanning tree protocol, that means we're going to elect a root bridge. Now, how do we know where the root bridge is at here? Well, the root bridge is definitely switch 2 because switch 2 has 2 ports here. Each one of these ports are live. And a root bridge would never have a port that's in a blocking state. It would always have ports that are live. So let's look at what the instructions they have here, and we'll go through these and we'll look at the port states of each one of these. And we'll see that these are designated ports. And we'll start with switch 2. Let's go ahead and start with that. And we'll just put in the one command line that they give us here, which is show spanning tree for VLAN 1. And what you can see here is all of the ports here, G01 and G02, are set to a designated port. So one of the things that we can take away from this is that if you are the root bridge, then you will have all of your ports will be in a designated state. So you can see they're designated and they're forwarding. Now, let's move switch 2 over here and let's grab switch 1 and let's see what that looks like. So we'll take switch 1 and we'll do the same thing. Oops, I didn't want show run. Show spanning tree VLAN 1, more like it. And look at the ports that we have here. So for G0/1 and G0/2, here's these 2. One of them is set as a root port, and the other one is set as a designated port. Okay, so what is a root port? A root port is a port on a device that's going to be forwarding information towards the root bridge, right? So it's forwarding it towards the root bridge, so that would make that a root port. So G0/2 is a root port, okay? G0/1 is just set as designated, and that's fine. Now let's get more interesting, do it a little more interesting. Go to switch 3. It's the same thing. Show spanning tree. And now this one's got some interesting states, right? So G0/1, G0/2, G0/1 is set as a root port. Hey, that's exactly as G0/2 over here, right? Because it's forwarding information towards the root bridge. So any port that's forwarding towards the root bridge that's live is a root port. You would think that the names of the ports on the root bridge would be root ports, but they are not. They are designated ports, and the root ports are on switches that are not the root bridge. So just kind of a little thing on that. And then look at G0/2. G0/2 is the only port in the system that has an amber light, which says that it's in a blocking state. So it's not forwarding, it's blocking here. And it is an alternate port. Alternate means that we're going to just go ahead and not use it right now. So if we were going to move information from switch 1 to switch 2, at this point it would leave switch 1, leave PC1, hit switch 1, go to switch 2, and then go to PC2. The path across the other way would be a failure. So that's essentially what they're asking here in step 2. And then when we get into part 2, they're saying, oh, okay, hey, let's do this. Let's delete this link and see what happens, right? So use the delete tool and remove the link between switch 1 and switch 2. So let's do that. So we'll go here, and now it's gone. And then let's watch what happens. And look what happened is the port that was in a blocking state is no longer in a blocking state. It is now in a forwarding state, and it is a designated port. So just, for fun, quiz yourself. And I just told you one of them. If we were to look at switch 3, you'd see that G0/1 is a blank kind of port, and G0/2 is a blank kind of port. G0/1 is still going to be a root port because our root bridge didn't change, and G0/2 is going to be a designated port. Let's see if that is true. And you can see that it is true. So it went from a alternate port, G0/2 went from alternate port to a designated port. Oh, okay. All right, seems cool. And then if we look at S1, G0/1 was a designated port, right? It was a designated port. And now it is going to be a root port because it's going to be forwarding towards the root bridge. So let's see if that works. And sure enough, you can see the change here as it's changed into a root port because it's forwarding towards the root bridge. So any port, even if it's not directly connected to the root bridge, that's fine. If the traffic is migrating towards the root of the tree, then that's where it's at. Okay, so that is what they're giving to you in this particular lab. If you did some pings, you'd see they would be able to ping each other. There is a minor amount of downtime when you do switch across these. Remember the whole listening, learning, forwarding, blocking stages from your training. There are also presentation videos on this subject, but this is the only packet tracer video we have. So I'll tell you what, I'll see you in Module 6.